Alright guys, we're going to build on yesterday's stuff, and we're going to talk about a special type of relation, and that's pretty much all you guys are typically going to work with, is these special types of relations called functions. Okay, so for the most part, we almost always deal with functions in high school math in Alberta. So, a couple definitions just to get us started. The first set in the relation is called the domain, and the second set in the relation is called the range. So for this relationship that relates the number of wheels to a vehicle, this one here we would call the domain, and this one here we call the range. Okay, so the domain is the set of all input. That's the domain. So what do you think the range is? Set of all output. Okay, do you remember those input-output machines from elementary school? You input a number and then you output a result. So like if you, in this relationship, if you inputted a 1, what would it output? Unicycle. That's one wheel. If you input a 2, you could get a bicycle or you could get a motorcycle. For the input of 2, it has 2 arrows leaving it. Okay? So if we go up to this last definition at the top, it says a function is this special relation where each element in the domain is associated with exactly one element in the range. You can summarize that in this phrase here. One-to-one. Okay? So that first example, I'm going to highlight it for you, does not represent a function. Why does it not represent a function? Because good, 2 has 2 options that we can't have. Alright? Each element in the domain is associated with exactly one element in the range. So that first relationship is not a function, and we would say this, not a function. Okay, and that's typically how it's written, like it's like a handwritten F like that, lowercase handwritten F. That's how a function typically is written. Now if you look at the second one, this one just like reverses it. It's the exact same relationship, it's just reversed. So the domain and the range have switched. The domain and range have switched. Now this one will be a function because you can see there's only one arrow leaving each one. If there's only one arrow leaving each one, that guarantees that it's only going to be one output for each input. One output for each input. And that guarantees that it will be a function. This diagram represents a function. Because it's one-to-one. That's what a function is. Alright, so let's take a look at what they're going to do here. The domain is the set of the first elements. Remember that we use this symbol here to denote the set. It's just a squiggly bracket like you know on the computer, on the keyboard. On the keyboard there's a squiggly bracket. That's all it is. I'll draw a bunch on the board for you to help you. Like I usually, it's just like, it's kind of hard to do at first. Then you get it. And then you have to close it as well. Okay, and then you can put stuff inside there. What goes inside the set? Elements go inside the set. So what would be the domain for the second one? Bicycle, car, motorcycle, tricycle, unicycle. That's it. What would be the range for the first one? Unicycle, bicycle, and so on. And the range for the second one? Just 1, 2, 3, 4. Okay? And we will have a whole lesson on domain and range when the time comes. Right now, this lesson is mostly about functions. So we're going to look at some relations, and we're just going to decide, are these relationships functions or not? So that's what we're doing. Functions or non-functions. That's all we're going to do here. And they're going to be given to us. Oh, they've done it for us. These relations are functions. So why? Why are these functions? Why are these relations functions? What are you checking for? Each x has only one y. So look for the x equals 2. Is there only one y for that one? Same with this one. X equals 4. Is there only one y for that? How would you make this not a function? Look at this one. Look at x equals 12. When x equals 12, y could be 10. Or when x equals 12, y could be 14. So that makes it a non-function. Because for that particular x, there's two y's. And that's not allowed. Each x can only have one y. Look at this one. When x is 1, y is 2. But when x is 1, y is also 4. So that's a problem. That's why it's not a function. So it's back up to the top. If you look at this chart, see how they're all different x's? So it's good. That's a function. Now for graphs, I'm going to show you how to do this with a graph. So you need, again, you need for each x, one y. So how can you check that with a graph? So remember that the x's, like here's x equals 1. The x's actually form vertical lines. How many times does it hit the graph when you draw this vertical line? Once. So for that x, is there only one y? Yeah. Let's pick another one. Let's do x equals -2. That would be 2 to the left. So that's this one. How many times does it hit this line hit the graph? Just once. Do you think that's always going to happen? Are you sure? Draw vertical lines. How many times do they hit? They only hit once. So for each x, will there always only be one y? Yes. That's what makes this a function. This is a function. This graph here, I think it looks like this, right? Will this one be a function? And how could you test that? Just test a certain x. Like test that one. How many times did that x hit? Just once. How many times did this one hit? Just once. So this one is a function. Yes, these are functions. Now contrast that with the non-functions. Like look at this circle. Pick an x value, like say pick x equals 2. So here's x equals 2. Where does it hit the graph? Right here and right here. So there's two y's. There's two outputs for one input. That makes that a non-function. That's a non-function. Yeah, just give him a tap on the hand. Can you just turn your music down? You shouldn't even have it on. This graph here, what does it look like? Is it the last graph but sideways? Is it like this? Oh, it's like but a diagonal. Thank you, sir. Thank you, sir. So you could do the same thing with this one here. Pick an x. Like, what's this x way over here? X equals, pick one. 7? Beautiful. So when x is 7, how many times does it hit the graph? Hits twice. So this is a non-function. And this is all summarized on the next page. It's called the vertical line test. Draw a vertical line through the graph if it hits more than once anywhere. It's not a function. Okay, so the vertical line test is just a way of testing x values. So this graph, these pictures show the first 4, those are all functions. Because when you draw these vertical lines, it only ever hits once on the graph. So that means for each x, there's only one particular y value. And then on the bottom one, you can see a bunch of examples where the vertical line hits twice. And I like, especially for these bottom ones, they included some ordered pairs. So when x is 5, y could be 2 or y could be -2. So this would be a non-function. All right, so let's do these ones. And you'll get at least a multiple choice question out of this stuff for sure. Okay, so the first one is function. Each x has only one y. That's the reason. That's what you'd put for the explain. How about part B? Okay, non-function, good. Why is it not a function? Because when x is 1, y could be 2 or 4, good. The next one is a non-function because it fails the vertical line test. When you draw a vertical line, for example, through x equals 4, it hits 2 times. So we would say it's a non-function because it fails the vertical line test. Now this next one's tough because it's just an equation. Y equals 2x plus 10. So if you're stuck on this, what you can do is you can build a table. I like to try some numbers that are easy. Like what if you plugged in x equals 0? 2 times 0 is 0, so then y equals 10. Plug in another easy one, like what happens when x is 1? 2 times 1 is 2, 2 plus 10 is 12. Okay, plug in a 2, what happens? 2 times 2 is 4, 4 plus 10 is 14. Now do you see the pattern? What's happening as the x changes by 1, the y changes by 2. Is that always going to happen? Yes. So this is an example of a linear equation. What makes it linear is this constant rate of change. Delta y divided by delta x. If you're in Science 10, you know what that is. This constant rate of change, that's called the what? What's that called? Slope. So this, yeah. Linear equations are functions. So this is functions, yay, happy, function, yes. Function, yes. What about E? What does it fail? Yeah, fails vertical line test, hits twice. Fails VLT, not a function. Okay, and what about F? Not a function. How do you know? Where does it fail the vertical line test? X equals 1. And if some people are still struggling with this, what does x equals 1 mean? X is a horizontal axis, so it's 1 to the right. X is left and right. So then you go start at the origin, go 1 to the right. Here's x equals 1. It's this grid here, this grid line. X equals 1. So when x equals 1, you can go up this grid line. And then you see y is 2 or y is 3. Y is 2, 2 or 3. Okay? So not a function. Okay, this next stuff is called function notation, okay? So I'll give that a quick highlight. That's a function notation. And I'm just going to write it a little bit bigger here. It's written like this. And it's read f of x. Okay, this is not like a multiplication or anything like this. What this means is if the input is x, what is y? Okay? And f is the function. The function is just a rule. It's just a rule. So for example, the function that we're going to be doing here is written like this. This is the function rule. You know how like you can't wear hats in school? That's a rule. So for this function, the rule is this. You're going to take that x, whatever it is, you're going to square it, and then you're going to add 1. That's the rule for this particular function. And that particular function will generate a graph that looks like this. Okay? Now in Math 10, typically we only work with the linear functions, the straight lines. But occasionally you'll get questions that look like this. This is more for Math 20, but you still will see a little bit of this in Math 10. Okay? And those functions, like those are used, like all your technology, like your iPhones, any sort of like a Google search engine, all computer programs, like they're built on these functions. And there's tons of them. Tons and tons and tons of lines of code, which are essentially these functions. Okay? So math pretty much rules. Alright, let's take a look at the first one. What does this mean right here? F of 2. Read this to me. F of 2. That's how you read it. F of 2. What does that mean? That means the input is 2. So what are the inputs? X's or Y's? X. So go find 2. When X is 2, what's the Y value? Good, right there. And then you go across. This is a 5. So f of 2 equals 5. When the x is 2, the y is 5. Can you do the next one for me? What happens when it's negative 3? What do you get? All the way up to 10. What about when f is 0? 1. Excellent. It's right here. Now, these three, they were all very similar because the input was given. What's different about the last one? Good. The output is given. So for the last one, you have to find a y value of 5. So let me erase all this. And let's do it a little bit differently. Now we have to do the 5. This is 5 for y. This is y equals 5. So which x works? X could be negative 2 or positive 2. Very good. You guys feel okay about this? Okay. Now, what we're going to do is we're going to do this algebraically now. So we always use brackets for substitution, and we're going to solve this one here, f of negative 2. So you write it like this, f of negative 2 equals, so we're basically, see this thing in the box where it says rule? What did we change? We changed the x to negative 2. So then on the right side of the equation, you have to change the x to negative 2. So you just substitute in, where you see an x, just put a bracket. And what goes in that bracket? Negative 2. Good. Negative 2 squared, that's negative 2 times negative 2, plus 1. Order of operations, do those BEDMAS, do that multiplication first. Negative 2 times negative 2 is negative 4? Positive 4. Okay, and then 4 plus 1 is 5. Okay? And we already know that one's true, right? Because take it, didn't we already do that one a bit here? What happens when x is 2? Y is 5. So when x is 2, y, pardon me, when x is negative 2, my bad. When x is negative 2, y is 5. All right. Let's do these ones at the bottom here. If you look at the bottom part of the page, it's f of something equals a number. So we are missing the input. We always input into the function machine, and then it's going to output a value. So for the function machine, we have to put something in there. This is the function machine, and it's going to output something. In this example, it's outputting a 3. So what do you input to get a 3? Well, and remember, this is f of x will equal some y. So the y is 3. So where is y equal to 3? Up here. What x value gives you that? Negative 3. Good. So this is negative 3. Okay, look at the next one. What x value will give you a y value of 1? So there's y equals 1. Which x values will work? I heard a -5. Do you guys agree? And 5 also works. And the last one, what are we trying to get to? F of x equals y. Which x value will give us a y of -1? +1? I don't know, I'm trying to zoom in here. Oh yeah, it's like halfway, hey? Roughly? So maybe it's 0.5? You guys okay with that? Sure. You guys getting frustrated or what? Cool on that bottom part? Okay, function notation, algebraic. So any function can be written as an equation in 2 variables. It looks like this. F of x equals y. Okay, or you can write it with the y on the left. Y equals f at x. Typically, this is how it's written. It's 2 variables. The y depends on the x. And how does it depend? Well, it depends on the function. So y depends on x based on f. So whatever the function tells you to do, it's going to take those x's and make them y's. For example, this one right here and this one right here. All it says is I'm going to take my input, which is x, I'm going to times it by 3 and then subtract 2. That's the function. Okay, look at this one. This one's a distance versus time. Distance depends on time. I'm going to take my time, times it by 4, and then add 5. That's all it is. One down here is a cost equation. The cost depends on n, the number of items. Okay, I'm going to take my n, times it by 25, and add 300. This one here at the bottom, I'll give you an example about that one. Cost, let's say each ticket is worth 25 bucks. You're selling tickets. So what happens when you sell one ticket? You get 25. What happens if you sell 2 tickets? You get 50. You sell 3 tickets, you get? So the cost depends on the number of tickets. What's this 300? That's maybe the initial cost. Maybe it costs like $300 to set up the party or something. Maybe you got to buy food and organize an event. It costs 300 bucks just to start with. You haven't even sold any tickets yet. So that's how it works. Okay? So let's do a couple examples and then you are free. Or it looks like one example. Okay. So here we have an equation that relates the volume of gas in a vehicle to the distance you've driven in kilometers. Okay? So would you agree that the volume depends on the distance traveled? Do you agree with that? If you travel more distance, are you going to use more gas? If you travel less distance, are you going to use less gas? Okay. So then you write it like this. V of D is how you say it. And it will always be like that, guys. In science, chemistry, physics, whatever it is, math, it's always the y of x, the v of d. Okay, and they give us an equation for that. Now, they didn't write it as perfect as I'd like, but that's okay. You can just write it like this. It's the exact same thing. It's the exact same thing. V of d is negative 0.08 d plus 50. And just so you remember, I'll switch colors here. This is the y, and this is the x. Okay? So VD, whatever it is, cost n, Cn, like whatever it is, it's y and x. Okay? So we've done this. Write the equation in function notation. That's right here. Now, it wants you to determine the value of the volume when the distance is 600. All you have to do is go and change what? Change the d to 600. It'd be negative 0.08 times 600 plus 50. And you just pump that into your calculator. I got 2. Did you guys also get that? So what does that mean? What does that number represent? If you travel 600 kilometers, 2 liters of gas remain. So for this question B, the input is given and you have to calculate the output. So for question B, input given, output needed. Now that structure is going to flip for question C. The input is given, the output is needed, that's going to flip. So now the output is given and the input is needed. Okay, I'll do this one in red, part C. What did they tell us right here in this equation? Did they tell us that the distance is 26 or did they tell us that the volume is 26? So watch what I do here. 26 equals negative 0.08 d plus 50. You have to change the left side of the equation, the v of d, to 26. And then you have to solve for d using algebra. So this 26, it comes from up here. So how do you solve for the letter d here? You're going to have to do some algebra. What's the opposite of plus 50? So you do that to both sides to isolate the variable. 26 take away 50 is what, negative 24? And then how do you isolate the variable one more time? Divide by the coefficient. So you have to divide by a negative 0.08. That will isolate for the variable. Negative 24 divided by negative 0.08, you get 300. What does this number represent? Well, if 26 liters remain, you drove 300 kilometers. The homework is there, page 270. That's your assignment. So you'll have an East block, as well as tonight you can work on that.